Hey, welcome back, 8th grade. Hey, we're pushing deeper into our book, Say It With Symbols, and the investigation 4 details. And so we're looking at problem 4.2. As I was preparing for this, I realized that there's a really big connection to the quadratic functions that we haven't explored a lot about with. So what we're going to do is today, and actually this week, we're going to take a little bit of a break from the Say It With Symbols book and push into our quadratic function books, which is called Frogs, Fleas, and Painted Cubes. And we're going to do investigation 1 and take a look at this because that will help us understand more of what's going to be going on in 4.2, 4.3, and 4.4 as we finish up with what we're doing. So let's take a look at problem 1.1 in our Frogs, Fleas, and Painted Cube book. All right, guys, I know this will be a little tricky because you don't have the actual book in front of you. Hopefully you'll be able to see the PDF copies that I posted to the Google Classroom in the math section and be able to pull those up, and that will be able to work through these some together. If you can't, I'll try to get you some paper copies after spring break for sure. All right, so 1.1, staking a claim, maximizing area. So here it is. Suppose it is the year 2100 and a rare and precious metal has just been discovered on Mars. You and hundreds of other adventurers travel to the planet to stake your claim. You're allowed to claim any rectangular piece of land that can be surrounded by 20 meters of laser fencing. You want to arrange your fencing to enclose the maximum area possible. Okay, this is pretty similar to like something you might have learned back in 4th grade for those who were in Mr. Wolf's class, and the gold rush. Same idea. Many people from all over the world came to an area near Sacramento in 1848 to try to find gold. And what they would do is they would stake a claim that would be their area that they would work. So this is very similar to what they're doing, but now it's a fictitious situation in the future happening on Mars. All right, here we go. Part A1. Sketch several rectangles with a perimeter of 20 meters. Include some with small areas and some with large areas. Label the dimensions of each rectangle. All right. So let's start off here. I'm going to do this kind of quick. So this is going to be 2. I gotta get all the way around. It's gonna be a rectangle. I'm gonna have a 2 on the other side. That would be 2 plus 2 is 4. So then perimeter would be 20. So then the left after that would be 20 minus 4 would be 16. So I know I'm gonna have 8 over here too. So it's gonna be 5, 6, 7, 8. So 2, 2, 8, and 8. Perimeter would be 20. Okay, another one. Let's try something to be similar here. How about if I do a 1, and this would have to be 9, right? So 1 and then 9. That would give me a perimeter of 20. What if I had 3? Let's see. So 3 here. Hey, I'm noticing, look at this. 2 plus 8, that's 10, and 2 plus 8 is 10. 1 plus 9. So if I have a 3 here, it's going to be 4, 5, 6, 7, right? 1, 2, 3, 4, 5, 6, 7. So this would be 7. So that's going to be that. Let's see if I do 4. Maybe 4. This is going to be, so I see that's one increase, the other one decreases. This is going to be 6. Okay, get the idea. And then we got 5. And 5. Cool. All right. A2. Make a table showing length, width, and area for every rectangle with a perimeter of 20 meters and whole number of side lengths. Describe some patterns you observe. All right, so I got my table here, and I've got these guys. So let's go ahead and let's work out this process. I'm going to start off with my smallest numbers here. So this is kind of a weird one. I know it's the length is not that. Let's put our length in here. Is going to be this guy. So I've got 9, and then the width was 1, and then area would be length times width, going to be 9. Okay, let's go to our next one. Length is 8, area is 2. So I've got 8 here, 2 here. This would be 16. Okay. Next one. Length is 7, width is 3. 7, 3, length times width is going to be 21. Next one I've got length is 6, 4, so 6 and 4, that's going to be 24. And then length of width is going to be 5 and 5 is going to be 25. Now, I want to make sure I don't miss any of these other length and width. So if we look up here at all these other rectangles, I could turn them all this way and they would still be the same rectangle, but the length and width actually would be changing this time. So what if I kept going with that pattern? So you're coming down here. So in this case, what if we took this one here and reversed it? So it made the length 4 and the width 6 this time. So it'd be 4 and 6. That's going to end up being a 24. Let's reverse this one here. Let's do a 3 and a 7. That's 21. Let's reverse this one, the 8 and the 2. So 2 and 8, it's going to be 16. And lastly, this one, we're going to have a 1 and a 9, and that would be 9. All right, so we had another final question on part 2 to describe some patterns you observe in the table. Well, I noticed that as I have these guys here, I have 9 here. I also, that repeats down here with the same answer as 9. The 8 and the 2 and the 8 is the 16. 7 and 3, 21, 3 and 7, 21. 6 and 4 is 24, 4 and 6, 24. And I only have this one here is the 25. All right, part A3. Make a graph of the data, length and area, describe the shape. So we're making length and area. All right, so I made my X and Y axes. I've got length down here and area going up here. They want us to plot points for length and area. So my first one is 9 and 9. So let's see, about 9 and 9 is going to be here. And I've got 8 and 16. So here's 8 and 16. 7 and 21. So 7 and 21. 6 and 24. So 6 and 24. 5 and 25, which will be here. 4 and 24. 3 and 21. 2 and 16. And 1 and 9 again. Okay. So there is our graph, and it asks us to describe the shape. Now, at this point, we have some dots there, but this could look a little bit like what we've been thinking about these parabolas would look like in this case. In fact, we can actually go in and do this a little bit more. Coming down, and actually, we could come all the way down here. Something like this. Something like this. Okay. So the shape of this is actually what we would call a parabola. That's what that shape is. Okay. So 4. How does the pattern in the table appear in the graph? Okay, so this table, remember how we showed that there was this combination of like the length kind of comes here and we had this repeating going on for each of these. Do we have that same thing showing up here? Well, look, here's that 1 and the 9. There's, they both had the 9. And then the 2 and the 8 gave us the 16. The 3 and the 7 gave us 21. 4 and the 6 gave that, and the 5 is that. So that repeating, that almost like a mirroring kind of happens. And it happens, you know, on either sides of this. Have that mirroring here, and actually happens, same idea here. You see we have this mirroring happening on either side of that line. So that's what we see how that pattern shows. All right, B1. What rectangle dimensions give the greatest possible area? Well, if I look at this for part B, the greatest area was this one, right? That was the largest area. And also look at the largest area was up here as well too. You see that? So the highest area. So the dimensions 5 by 5 equals greatest, oops, I can't write today, greatest area. B2. Suppose dimensions were not restricted to whole numbers. Would this change your answer? Let's see. So if I go in here and I look back at this information, I'd have decimal numbers would show up somewhere in here, wouldn't they? So let's say what we do is let's figure out something that would go like right in here maybe. What if we did an 8.5, right? 8.5, and this would be by a 1.5. Let's see what that would actually be. If I multiply that, 8.5 times 8.5 times 1.5, I'd get 12.75. Would that end up being the same place? If I come to 8.5, would I get 12.75? Look at that. I would. I'd get right there, wouldn't it? It wouldn't change anything at all. It would be exactly the same process. It would not change our answer. All right, 8th grade. So I know this is a lot. We just finished investigation 1, problem 1.1, taking the claim. Tonight for your ACE work, all you have is going to be numbers 1 and 2. It's going to be pretty similar to what we just did in class. So let's take a look at that one. All right. So just for 1 and number 2 in this case. So now look at this. Find the maximum area for a rectangle with perimeter of 120 meters. Okay, we just did it with 20 meters. Let's try it with 120 meters. So you're doing this, make your answers convincing by including these. Sketch rectangles, make a table of lengths and areas for the rectangles with a perimeter of 120, use increments of 5 meters for the lengths, and graph the relationship between length and area. Explain how each piece of evidence supports your answer. So you're basically doing what we just got done doing for our notes for number 1. And then look at number 2. What's the maximum area for a rectangle with a perimeter of 130 meters? As an exercise 1, support your answers with sketches, tables, and a graph. Okay? So you're finding a maximum area for 120 meters. Now you find the maximum area for 130. Do the same thing. You're going to make sketches of rectangles, make a table, and make a graph. All right, that's what we got going on. Hope to see you guys at the Google Meets this week. We'll go over all this work as well then too, and bring your questions, and we'll do the best we can with these quadratic functions. All right, see you later on and next time.